In this module, we're going to be covering the use of regression to help us make specific business decisions in a marketing context. Now, I know lots of you have covered regression in other courses, and that's the main reason we're actually going to skip over things like assumptions and necessary conditions to run regression. Now, regression can be used for lots of things, including decision-making, forecasting, and even interpreting the results of some experiments. And to get us started, I want to focus on a specific example, and for that example, we'll be using the Minute Maid orange juice dataset. And this dataset is a set of data from an orange juice producer, and we're going to set up the scenario as following. You've been hired as a consultant for the Minute Maid company, so Minute Maid is a major producer of orange juice. Before going for an important meeting with senior management, you have been asked to analyze the sales data for Minute Maid orange juice for the Southern California market. To assist in your deliberations, some data have become available for one of your key accounts, the largest grocery chain in the particular market that we're interested in. The database was collected from weekly store scanner data that captures information such as sales, the number of cartons sold, the price of the sale, and other promotion information for each product. Management in this case is particularly interested in understanding how different pricing strategies affect sales. So before getting into regression, we can take a look at the data set. So here we go. And we see that we have each row of data represents a week. We have the number of sales of orange juice in general. We have the number of sales for Minute Maid. We have the price of Minute Maid. We have the price of a competitor, Tropicana Premium, another competitor, Tropicana Regular, and another competitor, which is the store brand. We also have information, these are going to be 0-1 indicator variables, whether an advertisement was displayed for Minute Maid, Tropicana Premium, Tropicana Regular, and the store brand on that given week. So for instance, in this first row of data, there were 1,000 sales, 66 were for Minute Maid. Minute Maid charged $2.99, Tropicana Premium was $3.66, Tropicana Regular was $2.39, the store brand was $2.49. Minute Maid did not advertise, Tropicana Premium did not advertise, Tropicana Regular did advertise, and the store brand also advertised. So one of the things we could do is take a look at the relationship between something like price and sales. So here I'm going to put up a graph where we have the week on the x-axis, and on the left y-axis we have the number of sales of Minute Maid orange juice, and the right axis we have the price. So kind of eyeballing this, it's actually pretty difficult to understand if there's such a relationship. So instead, why don't we look at the graph in a slightly different way, and what I'll do is I'll plot a scatter plot such that this time price is on the x-axis and sales are on the y-axis. And so what we see is it looks like there's a pretty clear negative relationship, such that as price increases, sales decrease. Of course, the point of statistics is that we don't want to be eyeballing these types of relationships, we actually want to test for them. Now, one way you could do this, by the way, is with just a simple correlation, which we learned not too long ago. But a correlation doesn't actually tell us much about the nature of the relationship. It merely tells us that a relationship exists. And so for that, we need regression, and in particular, we'll be looking at a linear sales model. So we want to explain the variation of sales as a function of price. In other words, prices fluctuate, sales fluctuate, and we want to understand if we can explain the fluctuation in sales as a function of the fluctuations in price. So we assume that sales and price are related in the following way. We say that sales at any given time t, which is S sub t, is equal to some constant, which we'll call beta 0, plus the price at that time period, p subscript t, times some other coefficient, beta 1, plus an error term. We're going to leave the error term alone for now. We now are assuming that sales in week t is a linear function of price plus some randomness that we can't pick up, which is the epsilon, the error. And what we need to do is find beta 0 and beta 1. Because beta 1 actually is going to tell us the degree of relationship between price and sales. In other words, it'll tell us what happens as price changes to sales. So what we'll do is first look at how to do this in SPSS, and then I'll unpack the intuition. So in SPSS, this is pretty simple. We go to Analyze, Regression, Linear. And what we want to do is say, what are we predicting? Well, we're predicting the sales of Minute Maid orange juice, so MM sales, as a function of the price, Minute Maid price. For the time being, we're going to leave all other options as is, and we're just going to ask for SPSS to run this. And so we get a few tables, and we want to focus on a couple of them. First of all, the model summary. The model summary simply tells us the degree to which we're able to explain the variation in sales as a function of price. So if we look at the R squared, or in fact we can look at the adjusted R squared, which takes into account the number of variables that we've inputted into our model, what this tells us is that 40% of all the variation in sales can be explained by the variation in price. You could say this a different way. You could say that 60% of the variation in sales is unexplained by price. In other words, there's other factors that are driving the change in sales besides the change in price. Moving down to the coefficients, and actually I'll just take these and I'll transpose them so we can put some annotation on top. What we see is we can identify the beta 0 and beta 1 from our equation. So if you recall, we said that sales is a function of some constant plus price times some coefficient plus some error. And what we have here is this is the beta 0 and this is the beta 1. Over here we have the standard errors of these estimates, which are roughly described as the degree of uncertainty associated with these various estimates. And most critically, we have the t-statistics associated with the coefficients. So what this t-statistic tells us, and the significance that goes with it, is that this coefficient, minus 377, is in fact statistically different from 0. In other words, this coefficient predicts sales in some way. And the way that we can read this equation is if we wanted to know at any given time what sales were given a price, what we would do is we would say sales are a function of beta 0, which is 1092, plus beta 1, which is negative 377, times whatever the price might be. And we don't know error, so we leave that alone. And so let's say, for example, that we have price of $1. We would say that we would expect sales in that given period to be 1092 plus negative 377 times 1, which is equal to 715. And the other thing to note is that this coefficient is negative, which makes sense. What it means is that for every unit increase, for every $1 increase in price, we expect a decrease in sales. And again, that's intuitively correct. So this is the core of regression. And what I'll do in the next video is try to give you some of the intuition as to what's actually going on under the hood.